Let's take a look now at what the solids, liquids, and gas states of matter look like on a microscopic scale. So down to the particle level, when we have individual particles, and we can take a look at how those interact with each other and how those look relative to each other. We'll start off by looking at a solid here. So this represents a solid, this square box here with these particles in there all lined up nicely arranged. This is characteristic of a solid. A solid has this long range crystalline or very ordered structure. And at the moment we have it down at 0 Kelvin. Remember, Kelvin is a unit of temperature, and this is the coldest you can get. So let's increase the temperature a little bit here and see what happens. So as we increase the temperature, you can see that those individual particles are starting to wobble around, they're starting to vibrate. What they're doing is they've got a little bit of energy, and that energy that we've given them in the form of the heat that increased the temperature has allowed them to vibrate. But what you should notice about the solid is that the individual particles are just vibrating about a fixed point. They're all staying in the same order. The overall order of the system has not changed. If we cool it back down again, everything stays in the same position. Now let's heat this up until we get to a liquid. So we'll keep heating it up, they vibrate, and eventually they will get to a point where they look really disordered now. They're all jumbled over and they can slip and slide over each other. So those individual particles now are not in that very organized structure. They're able to slip and slide over each other. Now, one of the things that's similar between a liquid and a solid is that the volume is pretty much fixed, right? With the solid, the volume was fixed. It didn't fill up the container. With the liquid, the volume again is fixed. Now there's a little bit more space in between, but it's still mostly taken up by the particles. The volume is mostly taken up by the particles themselves rather than having lots of space in between. So liquids are slightly compressible. We could push them together a little bit, but not significantly. Now, if we increase the energy even more, increase the temperature, we'll eventually get to the gas phase. Right there, it's now in the gas phase. Look, these molecules or these particles are moving around, bouncing around, filling the entire container. So the volume is not fixed by the amount of material we have. The volume is the size of the container. And most of the volume in that container is space. The particles are not very close to each other. One particle spends most of its time isolated from the other particles, and then every so often they may bang into each other or bang into the sides of the container. This is very different to the liquid phase, where the particles are kind of almost always in contact with another particle, or in the solid phase, where those particles are really, really organized and are always touching or always next to the same particles. So running through that again, the solid phase is the phase that has the least amount of energy and the most order in the structure. All those particles are in a specific place and they just vibrate a little bit about a central point, but they stay in the same order. As we increase the energy, we increase the temperature, they're then able to slip and slide over each other in the liquid phase. So the specific place for each of those particles is not set and they can move around. This is what allows us to pour a liquid. When we increase the temperature even further, the particles separate completely and take up the entire container, and that's the gas phase.